Alright, so this is my original finite state machine for my line tracker final project. And some of these things that I use will be implemented in the next version, but not all of them. So like here, the thing that was really important that I continued to use was this, grouping of the sensors. So like if these two are activated or this one's activated, then we're gonna know that the left sensor is activated. And then if these two, I change it up in the second draft. So if either of these are activated, then we know we're in the intersection also. And then if these two are activated or this one's we're in the center, not the intersection, my bad. And if these two are activated or this one is activated, we're on the right, where that right sensor is activated. So that's something I continue to use. But here, like, I have a finite state machine with 8 states, so that gets pretty complicated pretty quick. And I have this circuit drew up. I have the circuit for it here. This is the initial circuit I had, and this works, but like, this is a lot of gates, and this is not like implementable for like a breadboard. I mean, maybe, but it's unnecessary. So then we have our finite state machine, my new finite state machine. And this finite state machine is a lot more simplistic than the previous one. So basically we have this is the state for like normal function, and this is the state we enter when we have an intersection. So here we have so initially, like, if we have the right sensor activated, then we're going to have to drift left. And if we have the left sensor activated, we're going to drift right. And then if neither of these sensors are activated, it's going to go into, go straight. But then if we also overturn the sensors, it can switch between the drifting left and drifting right, which I feel like might make it a little spazzy, but I'm sure it'll work out. So then once we see an intersection, we know we see an intersection when both the left sensor and the right sensor are activated. So that's when we go into the intersection finite state machine. So this basically has two functions. So the first function is going straight, and so as long as it's going to continue through the intersection until it knows that not left, center, and right are all true at the same time. So then after that, it's going to exit the state and go back into the regular state machine. And then I use counters for this finite state machine instead of a actual register, because I thought that'd be easier to implement. So then I have so when you exit this state, it's going to switch into the other ball, and it's going to be in this state now. So if we go into the intersection and we go straight, and then we leave the state, then it's going to switch over to here. So the next time we enter the intersection, we're going to be in this state, and this state is for turning sharp left. So we're going to be turning a sharp left until we see the only sensors activated is the center sensor. So that's how that works. And then the implementation for this is, so here's the implementation for this, and this is obviously a lot simpler than the previous circuit. So here we have we take in our 8 sensors, we use some gates, and we simplify that into left, center, and right. So then we have some logic here, basically just this is the keys, the 3 things that you enter the state or stay in the state. So obviously we enter the turning state when we see left, center. So left, center, enter the turning state here. And then another thing is while we don't see the center, and we're in the state's activated and we're in the left-hand turn state, so that's going to stay. That's another reason to stay in this state. And then the third reason to stay in this state is you don't see any inputs. So this is going straight through the intersection. So then here we have this is a register. It just keeps track of it's basically an intersection enabled state. And then here I thought was pretty cool. So here we use a counter. So the output of this goes into the counter for this. So anytime this gets activated, it's gonna give this shifts on a rising edge. So when we see the high, it's gonna switch states. So it's gonna alternate between the 2 states. And then then we have the turning. So We have our right wheel forward, which is always going to be going forward, and then our left wheel will be braked when we're making that sharp left-hand turn. So we have to have some logic for that. And like left wheel power boost is for drifting left, and then the right wheel power boost is for drifting right. So here, like the two things that make the right wheel go on is like, all right, so if the left sensor is activated and we're not in the turning state, so this comes from the turning state, then we're just gonna, that means we're in normal function. So we're just gonna like drift. We're gonna drift left by turning the right wheel on with more power. And then here the left wheel is activated with the same idea. So if we're not in the turning state and the right sensor is activated, we're gonna drift by turning power up on the left wheel. Not drift, but like turn slightly. And then the third output we have is the like left wheel forward output. And it's basically like the left wheel should always be on unless we're trying to make that sharp left-hand turn. So like if this sensor is high and if this counter is high and then this is high, we know that we're trying to make that left-hand turn. So we're gonna put the brake on the left wheel. So kind of works. It works pretty well. So here we have like, let's see, like the left sensor is activated. We're gonna turn the right wheel on with more power so we can drift. And then let's say the right wheel is on. We're gonna turn the left wheel on with more power. And then we went into the intersection. This is the first time we enter the intersection. So the left wheel is gonna turn off. We're gonna turn the right wheel up just so it turns quicker. And then the right wheel is going to be going forward, but the left wheel is going to be braking, right? So let's exit the intersection. So then we exit the intersection like kind of at a angle. It's going to try to correct for that angle by turning the left wheel on. And we'll go back to center. And then let's say we enter the intersection again. So we enter like a little bit of an angle. The left wheel goes up to account for that angle. And then we'll see the left sensor get activated. And we're going to go straight through that until we don't see all of these inputs. So like once one of these is false, then we go back to normal function, and the left wheel is gonna like boost forward to try to like counteract for any overturning we did. So yeah, it works pretty well. It's like a lot more simplistic than my previous circuit. So this is something I feel that I can actually build, which is a good thing. All right. Yeah, I thought the coolest thing I did in here was this counter, because the counter kind of enables us to like. I thought it was like a somewhat like a different way to use a counter, because then you can like, instead of just using like trying to figure out some sort of logic to activate this, we can just like keep track of what we can just use the rising edge of this to change this state in that state machine, because there's only two states, so we don't really need all that much logic in that. All right, thanks for watching. I hope you enjoyed this video. Yeah.